Howdy, guys, and welcome. We're going to present Follett's Island Marsh Restoration Proposal, which is part of the ESSM 689 Coastal Processes and Ecosystem Management class. The presenters will be Madeline, Kyle, Thomas, Melanie, Jenny, and Zachary.
So marsh habitats on barrier islands along the Texas coast are highly productive, and they provide calculable ecosystem services to both wildlife and humans. Follett's Island is a narrow barrier island. It's located on the southeast coast of Texas near the city of Freeport. It's characterized by low four-dune islands, productive back island estuarine marshes, and ecologically important seagrass beds in the adjacent Christmas Bay. The Texas General Land Office has identified Follett's Island marsh restoration as a priority issue of concern for the region's Coastal Resiliency Master Plan. Follett's Island has been subject to erosion along much of its length, and in the past 50 years has undergone a systematic loss of over 18% of the historical extent of estuarine intertidal marsh. So the figure on the right is from White et al. In 2004, showing that change over time in those habitat types. Evidence of erosion from wind-driven waves and parallel currents are seen as this on the center of the bay side of the island, where the shoreline appears scalloped. So in the next slide, we show a aerial image of historical aerial imagery dating back to 1944. And that shows the same scallop pattern, which suggests that the erosion is from natural forces. When you compare that, the historic shoreline to present day shoreline, which is in green on the map, we see that through time there has been a loss of habitat along the marsh margin. So much of the restoration work on Follett's Island to date has been conducted on the Gulf side of the island. The marsh itself is still in relatively good condition, and therefore direct rebuilding of the marsh or marsh creation is not really necessary. However, permanent protection of the existing marsh from development and continued erosion is crucial to maintain the ecologically and economically important marsh habitat on Follett's Island. So we propose a restoration plan that will help protect 553 hectares of marsh and adjacent seagrass and oyster habitats.
So the main way of doing this is approaching it on a three-tiered project. First is going to be preservation of habitat, and that is taking it out of private hands and trying to put it into a public trust or a preserve. Secondly, we're going to do erosion protection. We want to eliminate as much wave energy impacting the marsh edge as humanly possible, and a way of doing that is likely to be a living shoreline. Monitoring. We want an extensive monitoring project. This area is still unknown and is highly variable, very dynamic system. So both a remote sensing and biological monitoring is what we would ideally want to be able to get a better estimation of what is going on in this marsh system. So our objectives, one will be to protect the existing land disturb, acquire the land, place in conservation easement. Two, reef balls along the living shoreline western extent of the inland marsh margin. This is to reduce the incident wave energy. And three, develop a monitoring plan to assess the current, future extent and health of the habitat types in the project area. So both biological and remote sensing.
So large-scale restoration, especially when it's executed in a way that creates long-lasting and self-sustaining habitat, can require considerable investment of resources. So here we consider the economic benefits in order to evaluate the cost-benefit ratio of the proposed project. For objective one, which is land acquisition, it's estimated to cost just over $3 million. It would create 433 hectares of least disturbed contiguous marsh. And using the benefit transfer from an existing economic value study, the economic value of 1 hectare of wetlands equals $165 per year. So the total is $71,445 in value per year for our entire project area. So this is a really conservative estimate, and it uses the mean value of coastal marshes worldwide. It includes flood control, improving water quality, recreation, fisheries, habitat, carbon sequestration, as well as other commercial benefits. Protecting these marshes from development will pay back the purchase price of the land after nearly 28.5 years. Again, this is a conservative estimate. We do plan to investigate alternate plans for protecting the wetlands, such as working with private landowners to help them put their property into conservation easement. This may free up expenses, and we'll still be able to protect the ecosystem services and values that the coastal system provides in perpetuity. The second objective of the project will create a living oyster reef shoreline along the central north coast of the island. A total of 2.6 linear kilometers of oyster reef will be constructed approximately 250 meters from the shoreline, just seaward of the extent of the seagrass beds that run adjacent to the marsh margin. The proposed cost of the living shoreline construction is $900,000 per kilometer, which totals $2.34 million. For this project, we plan to use reef balls, which will provide three-dimensional structure and interrupt the strong currents that run parallel to the shoreline. It will also dissipate wind-driven waves and boat wakes from eroding the margin, which allows for natural accretion and growth in the tidal marsh. Oyster reefs also provide essential habitat to many estuarine-dependent species, and they are suspension feeders. So a single oyster can filter up to 50 gallons of water a day. This filtration can reduce phytoplankton blooms, convert nitrogen, and improve water clarity, which is really important for seagrass beds. It's expected that decreasing the water turbidity by reducing wave action along the shoreline, as well as through water filtration, will result in an increase in seagrass coverage adjacent to our project area. So a conservative estimate using benefit transfer from a case study in Mobile Bay, Alabama of economic value per kilometer of oyster reef is $1.1 million. And that totals $2.86 million in economic value for our project. That gives us an instant net benefit of over $500,000. The third objective is to develop a monitoring program for the project site to measure success. Pre-construction assessment will describe baseline conditions before any action is taken, and then post-construction annual surveys will be implemented to quantify the changes. This monitoring plan will help identify any habitat degradation quickly in order to implement future projects and ensure the long-term success and continued improvement of Follett's Island Marsh. The figure on the right is an example of adaptive management, and our monitoring objective is to inform the adaptive management of Follett's Island as the monitor and evaluate steps. In summary, the restoration project we propose will provide the surrounding community and ecosystems with economic, social, and ecological benefits that will far outweigh the initial costs of the restoration.
The total project site will span from the Blue Water Highway on the southern extent to the northern extent of the marsh on the north side of the island in Christmas Bay. Pompano Drive will serve as the western boundary, with the Coldwater Canal Christmas Bay intersection serving as the eastern boundary for the whole project area. The total project area will encompass 433 hectares of land. The reef ball shoreline will span 2.6 linear kilometers and is defined by the dashed line on the project map. And the netted feature will encompasses the whole project map whole project area on the map.
So the physical drivers of this area are basically wrapped around marsh loss. So fetch length combined with wind speed and wind direction is basically equivalent to erosion. Doing a USGS analysis, we found that the significant wave height for Christmas Bay, assuming a 2-meter water depth, is essentially 36.43 centimeters for a significant wave. This is similar to what we've found off of Sportsman Road in Galveston Island, where recorded waves measured up to 37 centimeters in height, with the average being about 5 centimeters. Reducing this wave energy is the primary goal for our shoreline protection. We want to take away this as a system to continue to destroy the marsh. The best way to continue this or to restore the marsh is to reduce the incident wave energy and to allow the marsh to accrete. So high accretion levels are what we're going for, and that shouldn't be a problem as we have high connectivity to the bay. So that means good exchange of water. Salinity is not going to be a major issue here. And we want to be able to continue to open up that connectivity, but reduce the amount of energy. So that's one reason we went with the living shoreline.
Extreme climatic events such as hurricanes, droughts, and freezes may have a negative impact on the marsh habitats in the area. 9 hurricanes have landed within 100 miles of Follett's Island since 1900. The most recent hurricane being Hurricane Ike caused around 215 feet of shoreline erosion on Follett's Island. With an island as narrow as Follett's Island, the shoreline erosion can quickly begin to affect the marshland on the base side of the island. The island is not wide at all, so any effects on that shoreline can quickly begin to start to degrade into the marsh habitat. Drought events are decreased stream flow and runoff from upland areas, which decrease nutrient levels and overall biotic health in the Christmas Bay. However, drought events also decrease turbidity caused by upland runoff, which may aid in the distribution of submerged vegetation. A big drought event in the 1950s in the area may have contributed to the distribution of many wetland species into Christmas Bay and other wetland areas, other wetland areas on the Galveston Island coastline. Freezing events are less common in the region, but aid in the regulation of species in the coastal marsh habitat. Mangrove species have become a big concern, as decreasing events may be allowing for the expansion of these species into new habitats. A study in 2014 found that black mangrove species on Fawlett's Island, which may be a concern for future competition in the marsh area.
Okay, so here in the red outline area is our project area, and it's mainly got 4 soils that we're looking at. In the southwest corner is the Follett clay loam, and that's the area that experienced most of the erosion, and it's very scalloped. Then for the primary of the interior of the island, you have the Madre fine sand. And then on the beach side of the island is the Mustang fine sand, and in the northwest corner you have the Igem clay. So the Follett clay loam is a depth about 0 to 4 inches, it's 26% sand, 37% silt, and 37% clay, with a moist bulk density of 1.22 grams per cubic centimeter, 4.7% organic matter, and has erosion factors Kw and Kf of 0.02, where Kw is the erodibility of the whole soil, Kf is the erodibility of the fine earth fraction material. The K values range from 0.02 to 0.69 based on the percent of silt, sand, and organic material. Your wind erodibility group, which the Follett clay loam is group 4, and that is the erodibility groups consist of soils that have similar properties affecting their susceptibility to wind erosion, where group 1 soils are the most susceptible and group 8 soils are the least. Your Igem clay is 0 to 9 inches, 26% sand, 29% silt, 45% clay, 1.4 moist bulk density, 0.8% organic matter, erosion factors of 0.28, and your wind erodibility group of 4. Your Mustang sand is 0 to 4 inches, 94% sand, 4% silt, 2% clay, with a moist bulk density of 1.56, 0.6% organic material, and 0.2 erosion factor and wind erodibility group of 1. Your Madre fine sand is a depth of 0 to 8, 94% sand, 4% silt, 2% clay, 1.56 moist bulk density, 0.6% organic matter, 0.2 erosion factors, and wind erodibility group of 1. And then the Tatlum and Tricosa mucky clay, those soils were in the northwest but don't really affect our project area as much.
So we're looking at erosion rate, which I was saying earlier was one of the main physical drivers that was causing our marsh loss. We'd seen upwards of 22 meters of marsh loss in 33 years from 1974 to 2017. One of the main reasons for this is the wave energy that is intercepting the shoreline. So we're seeing a fetch length to the northwest. One of our driving factors of erosion is our energy for our northwestern cold fronts. And so our northwestern fetch length is 3,862 meters. And you can see the red line being 74 shoreline and the white line being our 2017. So we looked at this project and compared it to a similar project in Galveston Bay on the backside of the island off the Sportsman's Road. And we'd seen a quick measurement of about 55 meters of erosion from 1974 to 2012, so the same time period. However, and this is approximately double of what the erosion rate we were seeing. And when looking at the northwest fetch length, we see approximately 6,550 meters being our fetch length. So it's approximately double the fetch length, and we essentially get double the erosion. Now, this is holding for the factor of water depth and several other factors, but on its basis, a longer fetch length contributing to a larger wave, and a larger wave means more erosion. So removing that as a factor would be one of the main goals for the shoreline protection.
The proposed restoration project will be minimally invasive to the habitats and animals of Falls Island. There are 3 federally threatened and 5 endangered species listed in the project area. The proposed project is not expected to impact any of these species in a negative way. The proposed protection of marsh habitat will protect essential habitat of piping plover and other wading birds, which have been shown to utilize the tidal flats along the bay side of the island. The species of turtles will benefit from the complex submerged habitats of both the oysterreefs and seagrass, which will provide both direct and indirect food sources. Critical habitat for the whooping crane has been designated in Aransas, Calhoun, and Refugio counties in Texas, as well as the Aransas National Wildlife Refuge. Brazoria County is on the extreme margin of the species migration corridor, and the proposed project should not negatively impact the marsh habitat that they utilize. The small stocky shorebird known as the piping plover winters along the Texas coast. Critical habitat for the piping plover is located near the project area, but should not be negatively impacted by the project, as all construction activities will be taking place greater than 250 meters from the marsh margin in open water. Red knots are a medium-sized shorebird and travel thousands of miles between Arctic Canada and their primary wintering areas like the Texas coast. Red knots are believed to use the beaches in Brazoria County near but not in the project area. Just like the piping plover, no harmful activities will occur that will affect the habitat of these birds. Sightings of the West Indian manatees are very rare along the Texas coast. Most sightings are individuals migrating or wandering from Mexican waters. It is very unlikely that these manatees would travel inward towards the coast from the Gulf to reach the study area. The hawksbill turtle is small to medium turtle with dark to golden brown shell with a streak of orange and red. Texas is the only other state aside from Florida where hawkbills are sighted regularly. Kemp's Ridley sea turtles are the smallest marine turtles in the world. Although there is currently no critical habitat for this sea turtle along the coast, both USFWS and NMFS petitioned to designate critical habitat along the Texas coast in February of 2010. Loggerhead sea turtles are named for their relatively large heads, which support powerful jaws and enable them to feed on hard-shelled prey. Although Texas coasts do not have any habitat designated, it is a large area for sargassum habitat. The loggerhead is the most abundant turtle in the Texas marine waters, and again has been recorded in the study area, but no nests have been recorded. Leatherback sea turtle is named for its lack of a hard and bony shell unlike all other turtles. Sightings of leatherbacks are rare along the Texas coast as they like to keep to deeper offshore areas where their food sources occur. There may be some minimal disturbance to current oysterreefs with the construction of the new reef ball due to minor sediment resuspension that will occur as a result of the barge and reef ball installation, but the benefits are expected to outweigh these minor disturbances. We anticipate that there may be some minor initial damage to the existing seagrass beds during the installation of the new reef balls as a result of shading and sediment resuspension, but the damage should be minimal as all reef ball construction will occur seaward of the seagrass beds that run adjacent to the shoreline. The salt marsh on Falls Island are threatened by sea level rise, subsidence, and development. The hope of the project is to provide protection from further development and create an atmosphere that encourages natural accretion within the marsh. Currently, there are large tracts of wetlands on Falls Island that have been acquired by state agencies and NGOs and are being managed as conservation lands. There are 16 different private property owners within the proposed project area with a total value of nearly $2.03 million. Ideally, we would want to purchase the entire project area and place it on a conservation easement, but depending on landowner interest in funding, this may not be possible. In that case, where we are unable to purchase private property, we would work with the landowners as stakeholders to educate them about the project, as well as assist them as they should be interested in putting their property into a conservation easement. Acquisition of private property near the marsh margin adjacent to reef ball living shoreline will be prioritized.
So in order for us to move forward with this project, we need Nationwide Permit 54 or NWP 54, which authorizes the construction and maintenance of living shorelines, which consists of natural and man-made materials for shore erosion control. It must have a substantial biological component, either tidal or locker stream fringe wetlands, or oyster or mussel reef structure. And this satisfies Section 10 of the Rivers and Harbors Act of 1899, which essentially requires a permit for construction of any obstruction in navigable waters. And this permit can be issued by the Army Corps of Engineers Galveston District. We also need a miscellaneous easement, or ME, which is issued on both coastal submerged lands and state-owned uplands for projects which require right-of-way on, across, or over state-owned lands, and that is issued by the Texas General Land Office. For this project, we estimated that we need about 2,600 bay ball reef balls, and the bay ball is just the style of the reef balls, which is 3 by 2 feet in size, and it weighs about 375 to 750 pounds, depending on your sediment type where you're putting the material. And that can be seen on the image to the right, which has a barge and a crane and some reef balls. We also will need a crane or a barge, so we decided to go with the PM 1045 construction barge equipped with a 50-ton American crane and a contractor crew, which can be rented out from Peninsula Marine Inc. We also need high-quality remote sensing and ground truthing data, which you can get from Wilson & Company Inc., and we're going to use those as a monitoring plan to assess the current and future extent and health of the habitat types in the area.
This is our total project map. The red polygon depicting our total project area, and to the northwest, the line is the reef ball project area. You can see the oyster reefs that are connected to our reef ball project area, and also a cross section of Follett's Island, with Christmas Bay and Gulf of Mexico on either side. And this will be our living shoreline project map. You can see the oyster reef up close more, and the total extent of the reef line project area.
Okay, our final main objective of the Follett's Island project is to establish a long-term monitoring program. And this program consists of an initial baseline analysis of the site prior to our restoration interventions, followed by 10 years of annual assessments. And the goal of this is to capture the current conditions first, and then to track improvements as interventions take place, so that we can quickly detect degradation in order to inform any adaptive management actions, and then ultimately leverage this documentation we're creating through our monitoring process to increase support and funding for the project. And we'll be monitoring several measures of project success and using a variety of techniques to track them. So first off, using high quality remote sensing technology and aerial imagery. I'll be using those to track the spatial extent of the marshlands, flats, oyster reef, and seagrass on site. Also tracking the observable impacts to any current or wave action. And then creating a comparison to the historical visual monitoring data we have. Next, using a feldspar clay marker layer on the sediment surface to track sediment accretion and erosion in the marsh as these changes are taking place and changing the elevation and the relative sea level. And then finally, on-site sampling and ground truthing will be used to inform the remotely sensed data used to map the habitat types. We'll be using it to check for presence or absence of flora and fauna species, including especially species that are used for local recreation and fishing. We'll be checking recruitment, abundance, density, and size of shellfish populations on the living shorelines that we'll be implementing. And finally, sampling water quality through changes in nitrogen content, in water clarity, and in salinity. The proposed timelines of the project objectives are all interrelated, particularly in the case of the monitoring program. That monitoring program will begin before both land acquisition and construction of the living shoreline, with an initial assessment of the baseline conditions prior to intervention. After the initiation of restoration activities, the annual assessment program will extend for 10 years at least, with the option to continue monitoring conditions after that point. The acquisition of land as a part of Objective 1 will be an ongoing process throughout the monitoring program's 10-year timeframe. And Objective 2, the living shoreline construction, will take place in year 1. It's anticipated that the reef balls we'll be using to found these living oyster reefs will be about 70% populated with oysters within 1 year of construction. However, the full realization of natural characteristics within similar restoration projects has been shown to take more than a decade in some cases. So that's another reason it's critical to have that long-term monitoring process. And so finally, in terms of the project lifetime, this project is a large-scale restoration, and it's planned in a way to create long-lasting and self-sustaining habitats on Follets Island. Through land acquisition, the goals to that end are going to be to, first off, prevent the encroachment of human development, thus allowing for the marsh to mitigate for sea level rise by accreting sediment. And then also on that note, it'll prevent the introduction of inflexible structures from human development into a fluctuating environment that is not a sustainable place for them. In terms of the living oyster reef, that will serve as a breakwater to slow wave and current erosion and allow for accretion to occur in the tidal marsh at rates that can actually try to keep up with the impacts of sea level rise and climate change. The monitoring program will be enabling adaptive project management. And by doing that, it'll provide access to the current data that we need in order to reevaluate and adjust our project objectives as we go. Now, some uncertain factors that may impact the project lifetime are major climatic events such as hurricanes, tropical storms, drought, etc. These factors may introduce that element of uncertainty to the restoration, but they aren't reasons to abandon the restoration project because the project is aiming to improve resiliency to those very events. And finally, careful coordination with ongoing beach nourishment efforts and other local stakeholders is important for developing a long-term plan for protection of Follets Island. For instance, if any future acquisitions or ecological shifts determine a need for a planting plan, then one resource might be the Galveston Bay Foundation's March Mania. Their community engagement program provides an additional opportunity for us to foster local support while enhancing our project at the same time.
So in summary, the Texas General Land Office has identified Follets Island marsh restoration as a priority issue of concern for the region's coastal resiliency master plan, and in part because of habitat loss due to erosion, development, sea level rise, and subsidence. So in this proposal, we suggest 3 objectives, focusing on preserving existing marsh, protecting degraded habitat from future erosion, and monitoring the before and after impacts of the proposed work to accurately quantify the ecosystem improvements that are attained as a result of the work. Using a benefit transfer from existing economic value studies, we demonstrate the cost-benefit ratio of the project and are confident that the project we propose will provide the surrounding community and ecosystem with economic, ecological, and social benefits that will outweigh the initial costs of the project. As for the project considerations, we investigated the physical drivers that affect the project area, including waves and sea level change. We also considered the climatic drivers that are known to impact coastal habitats, such as hurricanes, tropical storms, and extreme weather events. We also provided information on soil types and compiled and provided potential explanation for the erosion observed in the proposed living shoreline project area. The proposed restoration project will be minimally invasive to the habitats and the animals of Follets Island, and risk assessments were completed for all federally listed species that could possibly utilize the project area. A detailed project plan was provided with maps that depict the study area, habitats, and design of the proposed work, and the proposed project is an 11-year project with 1 year of pre-construction baseline monitoring and annual monitoring efforts continuing a decade after construction. So if funded, the project will provide protection to 553 hectares of coastal habitat and create 2.6 kilometers of oyster reef. The proposed project takes into account ongoing beach nourishment efforts and coordination with local stakeholders and provides an important protection for the marsh habitats on Follets Island. In summary, the restoration project we propose will provide the surrounding community and ecosystem with economic, social, and ecological benefits that meets the needs of the region's coastal resiliency master plan. At this time, we'll take any questions.